Let's go to page 33, number 38. So read the poem and translate. It says K takes 30 minutes less than M. So this is the time. So the time for K is 30 minutes or 1/2 hour. So half hour less than the time for M. To travel a distance of 30 miles, and it says K travels 1/3 mile per hour faster. So this is the rate. So the rate for the K is 1/3 miles per hour faster than the rate of M. And it says if X is the K's rate, so X is the K's rate. You're looking for K's time. Okay. So using the rate formula, so R times time equal to distance. Since you're looking for the time of K, so you have to use the K. So the rate for K, in this case, R of K is X. And the time would be TK. And the distance is 30. Okay. And so so time for K would be equal to 30 over X. And that's it. Let's go to number 39. So what's the value of X if 1 minus the reciprocal of 1 minus X equals to reciprocal of 1 minus X? Okay, so to solve this, I'm going to plus 1 over 1 minus X on both sides. So I got 1 equal to, this way, get 2 of them. And cross multiply, minus 1 on both sides, and times by -1. And so that's it for number 39. Okay, let's go to number 40. Okay, number 40, a train traveling from A town to B town. And meet with the accident after 1 hour. And the train stopped for 30 minutes. And then it proceeds at 4/5 of the rate. So I'm going to make R equal to X because that's what we're looking for. And so here R equal to 4/5 X. And it arrives over here 2 hours late. Now you have another scenario right over here. Now if the accident happens 80 miles further down the road, then it would be 1 hour late. Okay, now for this situation, what we need to realize is this, that this part and this part are same. So you can ignore that. This part and this part are the same. So only thing you have to focus on is this part right over here. Okay. So focus on this part right over here. Okay. So and we're going to write the equation. So for this part, again using the rate times time equal to distance. So over here the rate is 4/5x. The time, I'm going to use this as my reference. So this will take 1 hour more than this. Therefore, the time would be t plus 1. And the distance is 80 miles. Okay, so this is for this one here. Now this one over here would be just the rate would be x times time equal to 80. Okay. So now you got two equations. Now this is easy equation, so I'm going to simplify. I'm going to move this and to substitute into here. So I'm going to divide by x. So I got t equal to 80 over x. Then I'm going to substitute into here. And I'm going to add this together. So I got 80 plus x over x. And the x and x will cancel out, so it's kind of nice. So I'm going to multiply by 5, so I can move this over to this side. So again, I multiply by 5. And I'm going to divide by 4. So I got 80 plus x equal to 100. Then minus 80 on both sides. So x equal to 20 miles per hour. Okay, let's go to 41. So read through the problem. So this is the job problem. So let's go and make a table to organize our information. Okay, so you have Adam and Brenda, and this would be the time to complete the job, and this would be the rate. Okay. So Adam can do a job in 10 days, so that's 10. Brenda can do in 15 days. Okay, so by doing this, the rate would be 1/10. 1/10 means every hour he will finish 1/10 of the job, and the rate for Brenda is 1/15. Okay, so now go back and translate. So it says after Brenda works for 3 days, okay, so 1/15 times 3 days, and Adam and Brenda work together, so plus, so they work together to finish the job. How many? So go and times it by number of days, that's x, and equal to 1 job. Okay, so this 1 means 100% of the job. Okay, so now just now solving this. So multiply, I get 1/5 plus, add this together. So common denominator will be 30, so it'll be 2 and 3 will be 5. So minus 1/5 on both sides. So I got 5x over, I'm gonna simplify this. So I get 1/6. Okay, let's do this. Okay. Then after that, multiply by 6. So x equal to 24/5. So x equal to 4.8 days. Okay, let's go to number 42. Okay, so a car travels 120 miles from A to B. So 120 miles at 30 miles per hour. And so it's going and then return the same distance at 40 miles per hour. So you're looking for the average speed for the round trip. Okay, so you're looking for average speed. So you can R times time equal to distance. So you're looking for average speed. So R equal to D divided by T. So D, you have to use the total distance. So you're going 120 miles this way, 120 miles coming back. So the distance would be 240. Okay, and the time, so we have to figure out the time. So over here, the time is 30 miles per hour, and for 120 miles, so the T will equal to 4 hours over here. And over here, the T will equal to 3 hours. Okay, so 120 divided by 40 give you 3 hours. So the total time would be 4 plus 3 give you 7 hours. And so the R will equal to 34 2/7 miles per hour. Okay, let's go to number 43. Okay, number 43, again, is a car. So a car left the city at 2 p.m., traveled an average speed of 40 miles per hour. I can write down all the information. A second car left at 4 p.m. and traveled the same route and overtook the car at 9 p.m. Okay, what was the average speed of the second car? Okay, so from here we can see that the t equal to 7 hours, and from here this t equal to 5 hours. Okay, so over here using so r times time equal to distance, and since they're the same distance, they will equal, right? So over here the r times time will equal to the distance, which is equal to this, so equal to r times time. So divide by 5, so r equal to 56 miles per hour.